So let me get started again. Basically, it looks like most people got the hybridization right. What is it? SP? What is the electron geometry? Trigonal planar. Trigonal planar because there are three. Lone pair, and bond. And so it is trigonal. The trigonal planar means sp2. And so each oxygen is sp2. And then let's go ahead and figure this out. If it's sp2, we got three sp2 orbitals like this and a p. How many electrons does oxygen have? 6. And the way we fill it is we fill it to match the structure. And so if the structure shows 2 lone pairs, then we have to make sure we have 2 lone pairs in our energy level diagram. And we'll put 2 lone pairs in the sp2. That takes care of 4 electrons, and then we'll have a single in an sp2 and a single in a p orbital. And then we have to know how to draw these. And so usually we start off, when we do an sp2, we start off with a top view. And so this is sp2. How does that look? No. Does it look a little funny?
Yeah.
What looks funny about it?
Orientation of orbital.
This orbital. This orbital looks funny. This orbital should be. Yeah. Point it this way. This might be a little funny too, but what we see is we see the 2 oxygens like this. And these are all sp2 orbitals. This is sp2. And so we have 2 lone pairs here and 1 bonding. 2 lone pairs here. And so we see an sp2 sigma bond. Right? Mm-hmm.
So there's a double bond in the middle. Why aren't there 4 electrons in the orbitals that overlap?
Yeah, because we haven't quite finished yet.
Oh.
Shortly we're going to be done with this because there, in a double bond there's a sigma and a pi. So where's the pi bond here?
Up top.
Yeah, this is the top view. So there's a p orbital sticking up here and another one sticking up here. And so in the p orbitals we'll have a pp pi bond here. And so I'll call this the top view.
How do you know where you're looking when you're drawing?
Okay, how do I know where I'm looking? I just have it memorized. This is the top view. And then we have it memorized the side view. What would the side view of this look like? Well, before I do that, let's take a look at oxygen. Oxygen, the other oxygen is going to come in here and bond with an sp2 here. And so we'll have an sp2 sigma bond and a p here. So sp2 sigma bond, and this oxygen has a pp pi bond as well. 1.
Can we get a few more practice?
Yes.
Can we do a few more? Like, can you give us a few more for practice?
Well, do the side view for this. How about that? Can you do the side view?
When we do these on test, do we need to do both views?
Yes.
Oh, good question. What chapters is the test going to be on? Because the syllabus says 6, 12, 13.
12, 16.
12, 16, 14.
No 14.
Ever
12?
in this section?
Yeah. No 14 ever in Chem 1A. 14 is going to be Chem 1B.
So we're just doing
9, 10, 11.
12.
No 12.
9, 10, 11.
9, 10, 11. I was going to throw in some 16, but I didn't make it to 16 today, this morning.
That means you don't learn anything.
But we're going to do 16.
But just to know it that way, to appreciate it.
No, 16 will show up on the final.
Oh, okay.
We'll talk about it though more.
So what are we responsible for until the end? So 9, 10, 11 are the next test, right?
Yeah, 9, 10, 11 on the next test.
And then the final is everything we covered
And
plus
16.
16?
Plus 12, 13, 16.
12, 13, 16?
Yeah, 16 is very short though. I'm not doing the whole chapter.
Oh, God. So do you think if we just reference your notes, that would be good enough for the test?
Wait, so we're gonna cover 12, 13, 16 in like a day? 2 days?
No.
Like a week, right?
Yeah, in the last 2 weeks. we covered.
We are in the last 2 weeks.
But there's only like a bit, 2 classes or a few classes between final and...
Finals on the December 4th, 12th?
12.
December 12th, the final one.
I'm really scared. I don't know.
So
Or 11.
the ones that are sharing will be
11th, December 11th.
Yeah,
is
so
the
we're gonna
final.
have 3 classes before... between
What about
final
next
and
week?
Exam.
Next week on Monday, I'm not stopping lecture. The next week on Monday is going to be continue lecture.
But
Except
not-
I'm just not going to test you on it
Oh,
on
okay.
Thursday. That's all.
Yeah,
But
So
Final.
we're finishing up for this test.
today, that way you have the weekend.
Mhm.
Or you know, the other option is to include Monday's material, and that means less.
No, that's okay.
please don't.
Right. And so we have next week also. So there's more days than just. We got 2 weeks left.
these are
But for actually to give back to your thing,
yeah,
for chapter 12 and 13, yeah, if you study from the notes, that should be enough. Yeah. For those.
Mr. Professor.
Mm-hmm.
For the side view, you have the ones that are sharing the signal bonds will be in the plane.
Yeah.
And then you have the two.
The sigma bonds will be in the plane. Good.
And then so will the pi bond, right?
Yes. So will the pi bond. And so we have our sp2 sigma. It's in the plane. But with the side view, the p orbitals are going to be now looked in profile like this. So here's one p, here's the other p. So the p orbitals overlap like this.
So this is from the side.
Yeah.
Will it actually look like that, or will it be kind of in a diagonal?
What do you mean a diagonal?
Because if you look at when we were doing Lewis structure for 4 bonds, right? You'll have 2 in the plane, so you have one going up.
Yeah, but
one
that's
going
tetrahedral.
inside.
This is trigonal planar. And so what all we're doing is like this. We have this little trigonal planar arrangement of orbitals here. And in the side view, we're just twisting it so it's in the plane now, like this, horizontal plane. Here's a vertical plane. Put it in the horizontal plane. And then there's a p orbital that sticks straight up like this. So now it's looked at in profile. So it's the same thing.
Okay.
You know, if we look and label the orbitals, we've got sp2 here, sp2 here, 1p, sp2 here, sp2 here. Some people mislabel this. So on each oxygen, we have 4 orbitals, sp2, 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 and a p. But what some people do is they'll call this a p2. So it looks like we have 4 p orbitals. Are there 4 p orbitals? No, so don't start labeling. You know, when I see this, like this P here, I think this. I think somebody was going to label it like this. You know, this is the left side of the sp2, this is the right side. So I'll label both sides. Does that make any sense? I'll label the left side, the right side, and the top. And then let's label the bottom of the lobe. Does it make any sense? No, it doesn't make any sense. So don't start adding a whole bunch of extra labels. Because then we think we have more orbitals than we actually do. Got the 3 sp2s.
I have a question. And when you go to the side view for the P's, they're not necessarily sticking up and down. They're sticking like back and forth. Because when I see it turn to the side.
No, the side view for the P, it's straight up and down. It's in the plane.
Yeah, it's like
This is in the plane.
Because if you're looking on top of a circle and you turn it,
Okay. Yeah.
they come.
Right. You just turn the top
Oh yeah,
90
I see.
degrees.
I see. I see.
Okay.
I did 180.
All right. You want more practice?
Yes.
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 All right. Before we leave this, though, what do we use this kind of information for? We use this information to map out the electron cloud in the molecule, and so we're looking at electron cloud. How it's distributed. And so let's take a look at oxygen here. Let's go with the side view for oxygen. For the side view, I have electron density here. This is the sp2 sigma bonding density. This is pretty much holding the two atoms together. But in addition to the sp2 density, I also have the pp density here. And so I got electron cloud here above, electron cloud here below. And so the nuclei are going to be attracted to the negative charge density, so they're going to be pulled into the green and pulled into the blue, and the net effect is it holds the two atoms together. Okay, in addition to the pi bonding density and the sigma bonding density, I have lone pair density here. And so as far as the lone pair density goes, I'll just put that as green here. We got some lone pairs sticking out right here, and then a lone pair kind of sticking in here. And a lone pair sticking out here, and a lone pair sticking in. Yeah. And so can you kind of visualize how the electron density is in the O2 molecule? We can put electrons here. I got 2 electrons here in the sigma bond, 2 electrons in the pi bond, and then 2 electrons in this cloud, 2 electrons in this lone pair cloud, 2 electrons here and 2 electrons there. So this pretty much is how the valence electron density is distributed in the molecule.
So the hybridization geometry would be a trigonal planar, but if we draw it out with the side view, it's more like a trigonal bipyramidal.
Yes. This looks like a trigonal bipyramidal, except the problem with it is it's not trigonal bipyramidal because in trigonal bipyramidal we have 5 orbitals. This only has 4 orbitals.
Then wouldn't it be a tetrahedral?
It's not tetrahedral either. It's trigonal planar with 1 orbital stuck in the middle. So it does look trigonal bipyramidal for sure. Same thing here.
No, that's what I'm getting because these things. With the hybridization, it's one geometry, but when we actually try to draw it out, it's not the same geometry. You know what I'm saying?
Yeah. The thing with the trigonal bipyramidal is you have to be able to attach stuff to everything. Can you attach a chlorine on the top here and a chlorine on the bottom? No, this is like this. If you have a hydrogen atom, I have a hydrogen here. I want to attach a chlorine here and a chlorine here. Is that going to happen? Why not? Because, yeah, I got too many electrons. Right now, 3 electrons can be in 1 orbital. That would be a violation of Pauli exclusion. And so the key difference between this and a trigonal bipyramidal arrangement, in a trigonal bipyramidal arrangement of orbitals, the axial is not 1 but split into 2. And so trigonal bipyramidal, this would be sp3d, 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 and this bottom one is a sp3d. So this is actually 2 orbitals, not 1 orbital. This is just 1 orbital. This is 2 separate orbitals. This is trigonal bipyramidal. This is trigonal planar. Because this orbital is just 1 orbital, rather than 2 separate. So this one can only form a max of 4 bonds, whereas this one can form 5 bonds. When I say a max of 4 bonds, one of those bonds is a double bond, sigma and pi.
Can we get more practice?
Yeah. You want more practice?
Are we going to the lab today, and what are we doing in the lab today?
We were supposed to go into the lab today, but there's technical problems right now. Fortunately, we were going to go into and do Spartan today. Our tech guy came in this morning, but I just checked it while you guys were working on the problem. It's still not fixed yet, so I'll check it again.
Did you record your morning for the lab?
We didn't do it. We didn't do it over there. We went there this morning, and then I found out it wasn't working anymore. And it was working fine earlier in the semester. You want to do another one?
Yes.
Let's see, which one is do this one. This is a very unusual molecule. Try this one out. Okay, you can take a break also. It's break time. So.